Hello everyone, welcome to the control system. This is part 3 of lecture 6 on state space representation. And in this section, we'll just continue our discussions on forming a state space model. And let's start with the example. We already did some example before, but this is another example. So we consider the system with two mass, M1 and M2, and with the spring. So we want to find the state space representation of this system, okay? And the output is the displacement of the mass. So M1 is connected to the wall by the spring K, and it connect K1. It connect to M1 is connected to M2 by spring K2, and also M2 are connected to the wall by K3. Okay. So the first step, as we did before, is to find equation of motion. I'm not gonna show you how to get this equation, but this is based on Newton's second law. Okay, it's very easy. So M1, you need to consider the force acting on this M1, and the second equation is F equal ma2. But so F equal ma, and you have this force, and also u2. Okay, and you can derive it by yourself. I'm sure you can obtain this equation easily. So after that, we need to define the state variables. Before we only have one mass. Okay, now we have two mass. So the state should be the displacement of m1 and its velocity, displacement of m2 and also its velocity. So we have four state variables. Okay, you can choose x1 equal y1, x2 equal y1 dot, x3 equal y2, x4 equal y2 dot. Okay, in this order. So it depends on you. You can also choose y1 and then y2 and then y1 dot and then y2 dot. That's also okay. Okay, but in this case, I would just choose like this. And step three, we need to take the derivative. Okay, you can do it by yourself. This is for exercise. Okay, maybe 10 minutes is enough. After 10 minutes, you can come back to the lectures. And then this is the state space representation of the system. This is matrix A, and this is matrix B, and we have two input, U1 and U2. Okay. In the previous example, we only have one input, but now we have two input and four state variables. Okay. And this is the output equation, Cx equal this matrix C plus, not plus, time x. So x is just x1, x2, x3, and x4. So in this case, we are interested in, okay, the output is the displacement of the mass. Okay, so the displacement of mass 1 and also displacement of mass 2. So x1 until x4, you can do the multiplication from this row to the column. You will have x1 here. And then if you do the multiplication from this row to the column of this, you will have uh, y2. This is y1 and this is y2. Thank you.